Snowflake and Databricks summits concluded in the first part of June 2024 with announcements that can reshape our thinking about how we architect future state intelligent data and analytics architectures. By intelligent, I mean AI infused applications with co-pilots, assistants, agents, and so on. Welcome to episode number 63 of It Depends podcast, the world's most or least well-known podcast. This is the first podcast I'm doing where I am going solo. And the reason for that is because so many people have been asking me about my learnings from both Snowflake Summit and the Databricks Data and AI Summit in this month of June 2024 that I decided it'll be easier for me to compile my findings into one video, which hopefully you will find useful. The goal is to explore these announcements and understand the impact. I'm not interested in playing favorites and comparing which one has a better offering, but I will leave that analysis to you. And at places, we will discuss some of those topics. We will go in chronological order, starting with Snowflake, because that event happened in the first week of June, and then we will go to Databricks. I have to say there is no dull day in our data and analytics space. Every day we have either new players or there's some chess move. For example, as I'm recording this podcast, OpenAI is buying Rockset, which is a real-time streaming analytical database. So as you can already see, OpenAI, which is a AI model company, is now moving from models into analytics, which is exactly opposite of what Snowflake and Databricks are doing, which is that they are moving from data to analytics to AI. Now, it is unclear at this point whether OpenAI is going to move from models to analytics to even databases, because we're not sure whether it wants to own customer data or it just wants to harness the Rockset's artifacts and help build agents. So that is yet to be seen. Some of the key highlights that I want to point out before we go into individual announcements is that from what we have seen, customers want integrated solution. They're not interested in buying parts. They're not interested in saying, I want the best chassis, I want the best engine, I want the best music system in my car. They want to buy experience like an iPhone or Tesla. Table formats are a very big deal to a lot of us in the data space, but from the business point of view, they want outcomes. They're not necessarily that interested in whether it's Iceberg or Delta, and we will talk a lot more about Iceberg and Delta in this episode. We also see that the vendors are responding to this integration story by moving up and down the stack. This has major ramifications for the ecosystem players because these large vendors, and it's not just Databricks and Snowflake, this is true even for Google's BigQuery, even for players like Cloudera, also Amazon, Microsoft with Fabric. So there's a lot of turmoil in the ecosystem of these vendors because the ecosystem players now have to figure out what is their best approach and how should they expand their offerings. Going back to what does the customer want? They want outcomes. I was quite amazed to see how we are turning things on their heads. For example, we've all lived and known about SaaS as software as a service. But now people are saying, wait, that's an antiquated concept. It should really be service as a software. Some people are saying, oh, well, the acronym still stays SaaS, so let's just call it result as a service or outcome as a service or value as a service. But you can see that the emphasis is now on services. So with that, we are ready to jump into the announcement, but I just want to make one thing clear. In order to not clutter my announcements with, oh, this is GA, public preview, private preview, soon to be announced, and so on, I've kept that that piece mostly out of this discussion. So if you are going to use any of these new announcements, please check the vendor's latest documentation to understand what is the status. With that disclaimer, let's see how Snowflake is delivering the goods. So I am going to now go and share my screen here. So let's do this right now. So you can probably see a blank screen here. It says Snowflake Data Cloud, Snowflake AI Data Cloud. So that is the new moniker for Snowflake. The reason it's all white is because it's a build slide. We will go through various categories. So let's start with the first category, which is data management. In this, you can see the first thing we talk about is document AI and tilt. So what is Arctic tilt? So this is an integrated piece that I mentioned a few minutes ago, where I'm saying customers want an integrated solution. By integration, it means serve my data and AI workloads from the same architecture. I don't want silos. I don't want to copy data from one stack to another stack. Document AI is something that Snowflake actually introduced last year. This is based on an acquisition Snowflake did in August of 2022 of a company based out of Poland called Applica. It basically is a method by which you can attach to unstructured data, documents, PDFs. Document AI parses the document. It then understands what is the semantic model, and then you can start asking questions of your unstructured data. The model that is used is called Arctic Tilt. We'll talk more about Arctic models are Snowflake's open source native models trained by Snowflake. It's a mixture of experts, a model. Tilt is the smallest one. It is only 0.8 billion parameter model, and it is what sits under document AI. The other big news, probably one of the biggest news to come out of Snowflake and to some extent Databricks, is this whole acceptance of Lakehouse as the new concept. In fact, Lakehouse is becoming such a big deal that sometimes it makes us wonder how long will data warehouses exist. Lakehouse is basically a combination of a data lake and a data warehouse. In data lake, you get a lot of flexibility, some cost benefits, scalability of storing data in files like Apache Parquet. But Apache Parquet files are very hard for people, many of us who come from the SQL world, to operate upon. So Lakehouse basically brings the data warehouse capabilities on top of a data lake, and that is done through table formats such as Apache Iceberg, Linux Foundation, Delta Lake, and Apache Hudi. So those are the three big table formats. In Snowflake, last year, they introduced this idea of creating a materialized view which behaves like a Snowflake table, but actually it's pointing to a file on your object store like S3, which is under Apache Iceberg format. And that is called a managed iceberg table. In fact, Snowflake tuned the latency and the performance of this external table or materialized view to a point where it is almost as good as a native Snowflake table. That is called managed iceberg tables, and these tables went generally available at Snowflake's Data Cloud Summit 2024. The other interesting thing is we've said this for a long time, that Snowflake needs to have an external data catalog. It already has a data catalog internally, and that data catalog is called Polaris. That data catalog was already internal, but now it has introduced a new data catalog called Polaris, which is a technical metadata catalog, not to be confused with with full-fledged catalogs like Atlan or Colibra or Alation, Actual Data, Informatica Data Catalog. These are full-fledged reference data catalogs, but Polaris is actually only for technical metadata. It tells me about the Parquet files, where are they stored, the information about the columns, and so on. So the reason why Polaris is now available is because once we move into the lakehouse concept, we want to bring any compute engine to bear on the same data. So instead of making copies of data, the idea is that I should be able to run my jobs in Spark or Pandas or Trino, Starbuzz, Dremio, Snowflake's engine, any compute engine should be able to use the same files, but how do they know what is the metadata of that file? That is now stored in Polaris. So multiple engines. Now, Polaris can be hosted inside Snowflake, or it can be hosted outside of Snowflake as a Docker container managed by Kubernetes. What Snowflake announced was that within 90 days of their announcement, Polaris is going to go open source. Now, that was a whole big aha moment, except as they were about to announce it, and the keynote was going to start, Databricks went and bought Tabular. So we will talk about Databricks moves in the space of providing a catalog for Lakehouse in a few minutes. In fact, Polaris is now being open source in 90 days. You can even run Polaris on all your S3 data in, let's say, lake formation on AWS. 84% of Snowflake's business actually runs on AWS. While we are on this topic, we do have to mention that I already said there are other data formats. So how do you get compatibility across all of these table formats is a huge topic of discussion, and we will pick it back up when we go to talk about Databricks. But there are translation products already available. And again, we have more than one that's available. Microsoft Fabric, because of its close connection with with Databricks, because Azure Databricks runs on Microsoft, so Microsoft Fabric's native format is called Delta, which comes from Databricks. They use a product from a company called OneHouse, the same company that created Apache Hudi. And OneHouse has a product called One Table, which they built with Google and Microsoft. Now it is incubating as an Apache project called Xtable. So Microsoft Fabric uses Xtable to convert Delta into Iceberg. So you can already see that the interoperability of these various table formats are starting to happen. When we talk about Databricks, we will talk about uniform, but we will hold that thought for a minute. One thing that you do not get out of Polaris is fine-grained access control. You get coarse-grained at the file level, but what if you wanted it at row-level security, column-level security? So you want some attribute-based access control, data authorization at the cell level. For that, you have to go to Horizon Catalog. Horizon is not a new product. This was actually introduced in November of 2023 by Snowflake, but now Horizon and Polaris go hand in hand. Horizon is where you would find the typical capabilities you find in a standalone data catalog, such as business glossary, also lineage. It does offer a semantic layer, but this semantic layer is offered as a standalone YAML file, which is used by something called Cortex Analyst, which will be the topic for the next section. But before we end our discussion of Snowflake's data management capabilities, we have to talk about cost management. Snowflake has been a victim or has been receiving a lot of criticism for high cost, and they have managed to tune their database to be quite cost effective, but people want more cost management abilities. In fact, I would say every third vendor I saw on the show floor in the expo hall was offering some sort of cost management ability, including banks like Capital One with Slingshot. So the big announcement from Snowflake is that a lot of these cost management capabilities are now built right inside of Snowflake, such as budgets, cost transparency, trying to find the cost at at account level and soon at query level. So monitoring of costs, all that is very much a part of Snowflake now natively. So again, it goes back to my point earlier about how does it affect the ecosystem players, because they of course can say that we not only just do cost management for Snowflake, but also for Databricks, for Redshift, for BigQuery, and on and on. So they have that advantage of being multi-platform. But if you're only on Snowflake, then Snowflake now provides you a lot of built-in capabilities, as we will see as we proceed. So let's talk about generative AI. What is happening in that space? I already mentioned Arctic is the name of LLMs that come out of Snowflake. These LLMs, by the way, right now are only addressing code and text. They are not doing multi-model, but Snowflake has plans to make Arctic as multi-model models. Jensen Huang is probably at every conference I go to, he's always on stage. This time around, he called in from Taiwan because he was attending this conference called Computex, and he talked about how NVIDIA's NeMo framework for creating agents, copilots, RAG, etc., now also runs on Snowflake. Now let's go talk about some of the announcements. We talked about Cortex Analyst. What is Cortex Analyst? It's an agent. It's actually just a REST API on which you can build your agents, your business applications on top. What it does is it uploads documents, parses it into a YAML file, and then you can ask questions in natural language. It uses Meta's Llama 3 and Mistral Large as underlying models. It is very different from Cortex Search. Cortex Search is actually accessed through a UI like Snowsight, and it is meant to do hybrid text and vector search without having to write a single line of retrieval augmented generation code. So no RAG code needed. As opposed to Cortex Analyst, Cortex Search uses Arctic LLMs for now. And what can you search? You can search worksheets, dashboards, Streamlit apps, marketplaces, and other assets. The semantic layer is not a YAML file, it is automatically generated. So where does Cortex Search come from? Interestingly, this Cortex Search comes from the acquisition that Snowflake made last year, which is the Neva acquisition, and Neva acquisition gave Snowflake with Neva acquisition, Sridhar joined, and he is now the new CEO of Snowflake. So Snowflake has a very engineering focused leader. We got a chance to do a one-on-one with him, and we all came back very impressed, very engineering focused. The writings on the wall, engineers rule the world. Every company that had a sales or marketing head is now looking for a product or an engineering head. So that is just makes me feel happy to say that as an engineer. But let's get back to our normal programming and talk about Cortex fine-tuning. So what is Cortex fine-tuning? This is the ability to take a model. In fact, we saw demos of how easy it is to take a model, let's say Llama 3, give it your data, it creates a lot of intermediary tables inside Snowflake, but then you can then create your own small language model, which is very context rich and is tuned to your needs. So fine tuning is actually becoming a possibility now. We've been relying a lot on RAG, but RAG still does not give us the kind of accuracy that we want until we get into continuous fine tuning. So Snowflake made some good moves in this space. We will talk a little bit more about that, but let me talk about the last piece, which is called AI and ML Studio. This is a no-code development tool for citizen data scientists who can use natural language interface to invoke SQL and Python APIs. One thing that is very interesting that got very, very little airtime is machine learning. In fact, I heard at it was Databricks conference where one of the sales leaders was telling us that generative AI is what gets you the foot in the door of a prospect. Machine learning are the workloads that end up running. So machine learning is truly what people do. One of the biggest announcements was that Snowflake now has a native notebook. It's managed by Anaconda. It can run natively on inside Snowflake, or it can run in Snowpark container services, which can use CPUs or GPUs. So notebook is really an important feature. The other important feature is a brand new announcement is of uh, a feature store. So now you can have feature stores, features that can be stored. There's also model registry. Remember, we talked about cortex fine-tuning just a few minutes ago. So when you create these models, where do these models get stored? That is inside model registry. A lot of MLOps features through modeling functions. These functions can be called through SQL. And the big difference is that AI and ML Studio is actually the front end for almost all of these things we're talking about. But AI ML Studio is more for citizen data scientists who are not coders by profession. Machine learning is more for data scientists. So that's another big trend we see, that both Snowflake and Databricks are now trying to address the needs of data analysts, business users, data engineers, data scientists, all in a single platform. Data quality and security are very big topics. We saw the launch of Trust Center. This is Snowflake's user interface for discovering vulnerabilities and resolving security risks. Monitoring is actually very interesting because native monitoring capabilities actually belong under Horizon Catalog. And this is where you can define your data quality rules and you can monitor the health of your data. Once again, there are a lot of companies that do data observability, data quality, but only for Snowflake. And if you do that, then now you've got some pretty solid capabilities built right into Snowflake. We also saw data classification API. Once again, you can classify and tag your data right inside the database through this new data classification API. Data clean rooms, we will again see when we go to Databricks, they also announced data clean rooms going GA. Data clean rooms is giving your partners a safe place to collaborate. This is very common in media and entertainment industry where you are let's say a retailer and you have a lot of information about buyers on your website, but you need to share this data with your suppliers without sharing cookie data, because cookies are this hot button item which a lot of countries, Europe especially, they don't want cookies to be shared. So how can you share data with your supplier without sharing sensitive data is the job of data clean rooms. And this went GA at the summit. which takes us to the last piece, which is for application development. You have to understand that Snowflake is no longer a data warehouse, a data cloud. It is also where you are now building, managing, and serving applications. There are three types of applications that exist in the world of Snowflake. The first one is called managed apps. Managed apps are from third parties. Third-party providers manage the data, the code, and runs on top of Snowflake. The second type is called connected apps. In connected apps, the vendor or the independent software vendor, ISV, owns the code, but you own the data. So that data never leaves your account. But the focus is now on native apps. What are native apps? Native apps are apps where the code and the data both run inside your account inside of Snowflake. And this is the preferred method. This is, in fact, I sometimes talk to partners of Snowflake, and they are being asked by Snowflake that please move your app and make it a native app. That native app can run natively inside a Snowflake directly or on something called Snowpark Container Services. We talked about it when we talked about Notebook. A Snowpark Container Service is actually nothing but managed Kubernetes environment, except the customers never see Kubernetes part. They only know this is Snowpark Container Services. It can run not just on CPUs, it can also run on GPUs. Last year, after the Snowflake Data Cloud Summit 2023, I wrote my blog on sanchmo.medium.com, and I said that Snowflake now has 30 native apps. This year, that number is at 200, just over 200. And that includes things like, you want to do vector embeddings, use Pinecone. You want to do data ops, use dataops.live. You want to have graph capabilities, use relational AI. So that is a very big focus of running things as a native app. Now, the other thing that was also introduced is that a lot of DevOps capabilities and also GitOps have now been introduced directly into Snowflake. And these are done through this product called SnowGit. As you can see, it's got Git in its name, so we leave it there. Very interesting new capability that was introduced is called Snowflake Trail. Snowflake Trail is it's like CloudWatch or CloudTrail in AWS. It's monitoring the jobs that are running. It's monitoring the health. What I really liked about SnowTrail is that it adheres to the open telemetry specification. And if you are part of OTel specification, then you can use any OTel compliant tool as a front end for alerting, monitoring, notifications. For example, you can use Grafana or you can use Datadog. So with this, we are going to move ahead and we are going to talk about Databricks. Now, a couple of overall things that I want to talk about before we go into each category, like we did for Snowflake. First thing that I want to say is that a very big development out of Databricks is that it is now 100% serverless. It used to be that Databricks would create dedicated clusters. Ali Ghodsi was actually very clear in his talk where he mentioned that he does not want anyone to own your data, neither Snowflake nor Databricks. The data should be owned by the customers in their own account. But by going serverless, now you are not paying for a dedicated cluster. You're only paying per use. This is actually quite a lot of ramifications for Databricks, and I'm eager to see how this works out, because we talked about how Snowflake is considered to be this higher cost uh, offering, and that's because in Snowflake, you are bundling the underlying cloud costs like AWS and Snowflake together because it's a SaaS product. But in Databricks, those are two separate bills. So you only see Databricks bill. But once you go serverless, then that bill of cloud provider is now part of your Databricks bill. So we will see how that goes about. Now, I also had a question to Ali about the SaaS offering, and it turns out the SaaS offering is also coming, but in SaaS offering, the data will then sit inside of Databricks. So it's too early to talk about that, so I'm not going to bring that up beyond this on this episode. Serverless makes it really, really easy to run Databricks because we know how much configuration is required by Spark and all of these products. All that configuration just goes away in serverless. So great move. The other thing that I also mentioned here is that we see tabular acquisition. Tabular acquisition was timed right when Snowflake keynote was starting, came as a big surprise to all of us because we knew, some of us who were connected knew that Tabular was up for sale, but apparently a bidding war started and then Databricks won and they paid somewhere between $1 to $2 billion to acquire Tabular. This company has 40 employees, started by Ryan Blue and a few of his co-creators of Apache Iceberg when he was at Netflix. So more about that, but let's jump into our learnings category by category. You will see there are a lot more announcements in Databricks. I have to say that in my opinion, Databricks is taking more risk and is pushing the envelopes farther than Snowflake. For example, there was a heavy emphasis on agents. But make no mistake, Snowflake is not too far behind. So it's a neck to neck race. They're just taking a different approach. Snowflake is, as we saw, the AI data cloud. Databricks calls itself the data intelligence platform. So let's look at Delta Lake 4.0. This was announced. We talked about Xtable as the Apache incubating project to translate across all the three table formats. Delta Lake has something called uniform. So the first thing that I want to point out here, which is actually quite a basic thing, but it's a very nuanced point. When Snowflake talks about Iceberg, Iceberg is an additional format on top of its proprietary format. A lot of companies have a proprietary format and then they support a open standard. But in case of Databricks, they have only one standard, and that standard is Delta. So Delta is extremely important for them. So what they do through Uniform is that every time the Delta manifest file is written, they also create a Iceberg manifest file. We were told that the overhead of creating Iceberg manifest file is very minimal. It's like 2 to 4%. But by using Uniform, they are now saying that if your compute engine runs on only Iceberg, you can run it on Delta because we've already created through Uniform the Iceberg manifest files or the metadata manifest file. So that is the very big part of Delta Lake. The other big thing that they're doing is this automated workload optimization called liquid clustering. By understanding your workload, it is automatically sizing or resizing the cluster you have to give you the most optimal performance. A huge new addition is called Open Variant. Open because it's following open standards like Databricks does. Variant is the name of a new data type in both Delta 4.0 and Spark 4.0 to store JSON or semi-structured data in its native format. Prior to Open Variant, all of JSON data was stored as a string. When you have the entire document as a string, it's very hard and time consuming to parse it. So by giving this native data type, it is very easy to handle things like schema evolution, because if a column gets renamed, you just need to go and rename it in the native attribute rather than find it inside the string, and that's very cumbersome. So Delta 4.0 is the new the new storage format. A lot of new additions. It requires Spark 4.0. Renel Zinn, who is the one of the 7 co-founders of Databricks, he spent a lot of time on his day 2 keynote. Keynotes available, talking about what is new in Spark 4.0. Let's talk about Unity Catalog, because Unity, see, this is the interesting thing about catalog. Catalogs, the center of gravity is moving away from databases into the catalog. It used to be that if I wanted to read or write from tables, I would go straight into my database. But now the catalogs are mediating that access. And because the catalogs have security applied to it, like RBAC, ABAC, so they are actually the entry point to run queries. Unity Catalog is Databricks a product. It was announced last year, but now we can see it is coming of age. Another Databricks founder, Matej Zaharia, in his flamboyant flair on stage during the keynote, he walked across to his laptop, went to GitHub, went to the danger zone, and then he clicked on the button that made Unity Catalog an open source project. Made a big deal that you don't have to wait for 90 days, it's already open source. After the dust has settled, though, we are now starting to understand, and we're seeing that the Unity Catalog is an amazing catalog, open source, but not everything is open source. So we are hoping that Databricks will carry on its promise. For example, the user interface is not open source. You can access Iceberg tables in read-only mode. We don't know for sure if liquid clustering and open variant are also part of open source Unity Catalog or not. But one thing that we really like is the metric layer. So now we see that there is a metric layer inside Unity Catalog. This metric layer is critical when we talk about the last section in our discussion called AI BI. But for now, hold that thought. So why is it called Unity? That's because one of the things that it catalogs is data and files and AI models, functions. So it's truly the place where we see this integration of data and AI come to fore, because Unity Catalog is one catalog where you can see your AI models and data. By the way, Snowflake is also moving in that direction. Right now, their catalog is data only, but they eventually plan to add AI models on it. Unity Catalog is built on OpenAI specification, which means it has support for Apache's Hive Metastore and also for Apache Iceberg's REST Catalog API. Some other features that show up are like Lakehouse Federation. Lakehouse Federation allows you to connect to external data sources like Redshift, BigQuery, Microsoft Fabric, Synapse, or Azure Data Warehouse, and create some sort of like a semantic layer inside of Unity Catalog. So when you execute a query against Unity Catalog, it then translates it into the native format of the source, and it executes it there. So this the protocol that is used underneath the Lakehouse Federation is called the Delta Sharing Protocol, which is also a Linux Foundation open source protocol. By the way, a lot of Databricks open source offerings are under Linux Foundation, but Unity Catalog is an Apache Foundation project. We've talked about ABAC quite a bit. So attribute-based access control are built into Unity Catalog. They give you fine-grained access control. And then the last thing that we want to mention is this concept of lakehouse monitoring. Lakehouse monitoring monitors the health of your data and your pipelines. It's like data observability. It allows you to data quality, but not only does it find model drift data quality like missing values, duplicate values, all the typical data quality metrics, but it can also find out if your model is starting to drift and it needs to be fine-tuned. Well, I'm glad you mentioned fine-tune because we'll be talking about that very soon. But before we do that, let's talk about yet another brand new introduction, and that is data engineering. Lakeflow. Lakeflow is how Databricks wants to get rid of data silos, and it is bringing a lot of data engineering capabilities right inside the product. It has three parts, as you can see: connect, pipelines, and jobs. So what are these? So let's talk about the first one, connect. This is the component which is based on an acquisition of Databricks of a company called Arceon or Archeon. This company was building data ingestion connectors to a vast number of sources using change data capture. So it's real-time streaming ingest of data from different data sources using the Archeon technology. Lakeflow Connect allows you to bring data not only from databases like SQL Server and so on, but also from applications like SAP or Salesforce, also from data storage locations like SharePoint. So with this, you are able to bring the data, incremental data as well, not just one-time batch, but as the data changes, you get that incremental data. The next one is called Lakeflow Pipelines. Lakeflow Pipelines is the next version of Delta Live Tables, which were introduced over the last few years. Delta Live Table allows you to write SQL, Python to do data transformation. It's very interesting to see what's going on in this space because up to this point, you would need something like Fivetran to do your change data capture or your data ingestion from source into Databricks. Then you would put something like dbt to do your data transformation. But now you get these capabilities natively inside of Databricks. The last piece is called Snowflake Jobs. This is the orchestration engine. Also, it monitors health and the health of the pipeline. You can set up alerts, notifications, and you can use third-party products on top, like PagerDuty. So this is once again, you can see how Databricks is trying to get the data engineers, the data stewards, the data analysts, business people, data scientists, citizen roles, all combined into its data intelligence platform. Look at the number of announcements in generative AI. This is massive development here. So we'll talk about some of these one by one. The important thing that Databricks announced is called compound AI. It is a composable approach. So you can personalize AI through pre-training from scratch or no-code fine-tuning, create your small custom models. A lot of AI stuff is now branded under the label of Mosaic. If you remember last year's billion-dollar acquisition just before Databricks Data and AI Summit 2023 was Mosaic ML. So they've taken that Mosaic and they have branded their generative AI capabilities. We saw demos of how easy it is to train and tune your models. It's literally a UI with 3 steps. Step number 1 is you pick what is your pre-trained underlying model, that base model you're going to use, like Llama 3. The second thing you do is you pick what is it that you want to do. Do you want to train another model? Do you want to do instruction fine-tuning? Do you want to do code completion? So you pick the task, and then step number 3 is you point it to the source where the data is sitting, and then the system takes care of it itself. So that is how they are making it very easy to pre-train, tune models. One example of a company that is using Databricks to create its own model is Shutterstock. Shutterstock has a ton of images. You can do a text to image instruction, and the model that is used by Shutterstock was created using Databricks environment for generative AI. Vector search went GA, which is great. The next big thing, the next 3 things are Mosaic AI agent. So how do you create, deploy, test, and manage agents in an easy manner? There are 3 components for their Mosaic AI agent framework, and those 3 are an SDK, a way to evaluate the models. And this is very interesting because they have this concept of LLM judges and human judges. So you can supply your sort of golden Q&A data set, and you can refine the models by testing it against your data. In fact, any external person who does not even have a Databricks account can go into Databricks, and they can evaluate a model. And then finally, you can serve the model by creating a real-time API endpoint. I also want to mention that there's also MLflow, which is what came out of Spark. It's open source. If you don't want to use Mosaic, then you can also use machine learning through MLflow. And sorry for this one typo I have here, which I will fix. Okay, so one thing that we haven't talked about is this Mosaic AI tool catalog. So let's go talk about that. And I've also brought up the security features. So what is happening is that when you fine tune or you pre-train a model, that model needs to be stored somewhere. And for that, Databricks now provides Mosaic AI tool catalog. But I mentioned that through Mosaic AI agent serving, you get a real-time API endpoint. So now if we dip into the security, you see something called Mosaic AI Gateway. So Gateway is the ability to do rate limiting, permissions, credential management for model APIs. It's really part of Mosaic AI, but I put it under security because you can audit the usage of models. You can audit what data was sent or sent as a prompt, and what data was returned from models. So that's why you see Mosaic AI Gateway under security. There's also Mosaic AI Guardrails, which adds endpoint level or request level safety filtering. And this is how we can track if any PII data is being consumed or not. The next thing you see, LakeGuard. LakeGuard actually technically should fall under Unity Catalog because it's a part of Unity Catalog. It provides data governance on Spark workloads in SQL or Python or Scala, but it isolates users' code on a shared compute cluster. The last thing is data clean room. Once again, we've talked what is data clean room, and it also went GA for Databricks. So you can see that a lot of these developments are very similar in both the companies. What is happening is that there's some amazing economic and market forces at work here. Economic forces are very interesting because these co-pilots like GitHub Copilot and some of these products are now giving you very, very high accuracy of writing code. In fact, uh, Google Software Engineering just published a paper that shows that within the last 1 year, 50% of their code was generated through copilots. So the cost of creating software is going close to zero. A lot of models are now free, uh, especially open source models, but even ones from OpenAI. So because the cost is so low of developing software, that more and more software is going to be written. And that takes us to the usage of data. And so here we are talking about two pieces, business intelligence and data warehouse. So one of the most exciting announcements actually that came out was this concept of AI BI. AI BI is a new way by which Databricks is thinking people will consume data, build their dashboards. In fact, it has two parts. It has dashboards and it has a natural language assistant called Genie. Databricks is not new to the space of BI. It bought Redash in, I believe, 2020. And but it required when people talk about self-service BI, what do you mean by self-service? Who is it serving? It is really the data analyst so they can write better SQL statements. But that's not the problem. The problem is we want to enable business to ask questions. So if a business says, show me how my company's performance was in Q1, fiscal year 2024 Q1. What is fiscal year? What is Q1? What are the metrics that make up your company's performance? All that semantics you define through Genie. And by the way, where does it end up? In Unity Catalog, in the metric layer you see on top of the screen. And then you use AI BI, and you're able to use a BI tool in a much more intelligent manner. So this is how our roles will change. I also want to mention that one of the fastest growing parts of Databricks business is actually its data warehouse business. Data warehouse product is called Databricks SQL. It runs on its own engine called Photon. The new thing that we saw in the keynote was that Photon can now run on NVIDIA hardware, and so it gets this performance boost. So that is all we have for today. I hope you found this very useful. And please, if you can, subscribe to It Depends podcast, send your questions. This diagram that you see here is going to be published in my Databricks DAIS 2024 blog, which comes out in a few days. And we will be back with another exciting episode of It Depends podcast on Wednesday when some new news comes out. But until then, thank you so much for sticking till the very end and for following through uh, this uh, this talk, which is sort of happening in real time. And a lot of things that I talked about today will be very different in the weeks and months to come. So thank you very much. It's been a pleasure.